Hello everyone, welcome to this class today. In today's class, we are continuing from where we stopped yesterday, which is surds. And today we are going to do with operations with surds. What is operation? We talk about addition, subtraction, division, multiplication. But today we are focusing more on addition and subtraction. Now, let's go through this addition and subtraction of surd. Now, two or more surds can be added together or subtracted from one another if they are like surd. Before addition or subtraction, the surd should first be simplified if possible. Now, what does this mean? What they are trying to say is that before you add a surd, you must make sure that the surd form here and there are the same. Else, you are not supposed to add or subtract. If they are not the same, you're not supposed to add. Now, coming to the last paragraph where you say, they said the surd should first be simplified if possible. What they're trying to say is when you have a surd like this and like that, you can simplify it further first before you can add. Because if you look at this now, here is root 27, here is root 75, and here is root 12. A layman can just say, oh, they are not the same, so there is nothing we can do about it. But you can find out that on further simplifying this, you might turn all of them to be the same root, meaning that you can actually add or subtract. So that's what the last paragraph means. So let's dive into this exercise by solving these examples here from A to D. So let's start solving. For the number A, you can see that 4 root 2 plus 6 root 2. Now, first thing first, this is already simplified. 2 is the least root that can be inside the square root, while the same occurs here. And now, according to what we said, for you to add or subtract a surd number, the root must be the same. Now, in this case, this is root 2 and this is root 2 also. So we don't need to do anything. We just add it. So in this case, we're only adding the whole number outside. We're not touching this one. So the answer to this will just be 4 plus 6. Just add the number outside, root 2. So your final answer is 10 root 2. This is your answer. It's just a similar logic as when you have 3x plus, let me use the same number here, 4x plus 6x. So let's assume this root 2 is x. So when you have the same variable, you can just add it as 10x. But in the case where you have, let me say 4x plus 6y, you can't add this because x and y are not the same. So it's the same logic, I think. You can just picture it in that format. So in the second one, we have 3 root 5 minus 7 root 5. As you can see, this is the already rationalized. So there's nothing we have to do, and then both of them have the same root. So all we just need to do is just solve the question. We have 3 minus 7 root 5. Now 3 minus 7 will give you minus 4. So the answer is equal to minus 4 root 5. So this is our answer. So number C, this is where things start getting more interesting. As you can see, 3 root 8 is not the final simplification of this surd. Remember what I told you when we are doing the last class, that if you have a surd, even if the surd is in this format, but what is inside can further be simplified, the surd is not yet fully simplified. Because some people might say, oh, because it's in this form, it's okay. No, this 8 cannot further be simplified because this is 4 times 2, and 4 is a perfect square. So first thing first, we are going to simplify this and take it to the lowest form. In this case, we are going to have 3 square roots of 4 times 2. We are trying to simplify this number here. So we are not yet solving this, but we can solve it together. Okay, let me just solve it together. It will be plus this 50 is the same thing as square root of 25 times 2. Now 25 is a perfect square, so in that case we have 3 multiplied by square root of 4 multiplied by square root of 2. Now I'm solving for this part. Now let me come to this part. Plus square root of 25 multiplied by square root of 2. So the square root of 4 is what? 2. So I will have 3 multiplied by square root of 4 is what? 2. So I'll write 2 here, multiplied by root 2 plus square root of 25 already is 5, so it will be 5 times root 2. So 3 times 2 is 6, so this is 6 root 2 plus 5 root 2. Now this is a fully simplified version of this, and then both of them have 2 meaning that we can now solve for this. So the final answer will be, this will be equal to 6 plus 5, 6 plus 5 root 2. So the final answer is 11 root 2. So you see how dicey this was. Because it was not fully simplified, we have to solve further to get the final answer, to get this, and from there we are now able to add it to get this final answer. So let's go to this. Now we are having two operations going on here. We have addition operation and the subtraction operation. And now looking at this, you can tell very well that, oh, this is not fully simplified. So we are going to use almost the same thing we did here. Not almost, we are doing the same thing we did here. The only difference is that here we have we have 3 operations to do it. So now here is 27, here is 75, here is 12. Some people will be like, oh, they are not the same, so it cannot go. Actually, it can when you simplify it. So let's go. This is 2 square root of 9 multiplied by 3. Because 9 multiplied by 3 is 27. Plus square root of 25 multiplied by 3. 25 multiplied by 20 by 3 is 75. Subtract 5, 4 multiplied by 3. 4 multiplied by 3 is what? 12. So in that case, it will be 2 multiplied by square root of 9 multiplied by square root of 3. I know how you guys know how I translated this to this. I've said it so many times in this class that this is equal to this is equal to that. Whether you separate each of the digits that are multiplying each other in this form or you leave it in this form, it's still the same. We've proved it already in this class. So let's continue. Plus square root of 25 multiplied by square root of 3 minus 5 multiplied by square root of 4 multiplied by square root of 3. So we get, let me jump line so it will be more visible. We have 2 multiplied by square root of 9 is what? 3 multiplied by square root of 3 plus square root of 25 is what? 5 multiplied by square root of 3 minus 5 times multiplied by, this is square root of 4 is what? 2 multiplied by square root of 3. So let's solve. So 2 multiplied by 3 is giving, will give us 6 root 3. No, putting multiplication sign here and not putting is still the same. So plus 5 root 3 minus 5 times 2 is 10. 10 root 3. So now we already have the same root. Now we can add and subtract. So this will be equal to 6 plus 5 minus 10, or in parentheses root 3. You can even like I believe this is just simply like a case of where we have something like let me say something like let me give you an example. We have something like 5x plus 4x plus 6x, and you are being told to take away the common factor, which is x. Then the other one will now be left is 5 plus 4 plus 6. That's almost what we did here. So 5 plus 6 plus 5 is 11. 11 minus 10 is 1. So the answer is 1 dot root 3. So this dot stands for multiplication. So since it's 1 times root 3 is still root 3, so the answer is finally just root 3. This is your final answer. So as you can see, the long process we take, I have to take it step by step so we can all catch up. So what I will do is I will go to the example, pick maybe 2, the hardest ones, and solve them. I'll leave you to solve the rest by yourself. So let's go to it. So this is exercise 1D. So looking at it, we can say number 12. Let's look for another number we think that might take more time. I can just solve maybe 2 or 3. You cannot solve them. These ones is simple. They will have less work to do. So number 12, I think, is a whole lot of work. Also have number, let's say number 15. So let's solve this number 15 and number 12. Okay, let me add also number 11. So with this method we use, you can use this solve for the rest. So let's get into it. So this is number 11. Now we are being told to subtract this root 60 minus root 375 plus root 135. So now there's nothing we can do. We find out the roots are different, and we obviously need to simplify this what do you call it, this equation. So let's start. So to simplify this further, this is the same as 4 multiplied by 15. I've already taught us how you get to know which of these multiples or factors that we need. Just you need a factor that one side of it is a perfect square, while the other side is something that cannot be, you cannot find the square root. And then from here, the least you can get is 15 times 4. Let me also show the example. Let me show it in this one that is bigger so that we can subtract it from subtract minus, this one is 25 times 15. So let me show the full working of this for those that are not following us in the previous class. You have 375, right? Now we find the smallest number that can factorize it. I think the answer is 3. 3 go here, you have 1. 3 go here, you have 2. You carry 1. You carry 1 and put here 3 divided by 15. Let me write it here. You have 5. So the least number that can factorize 125 is 5. 3 5 go here, you have 2. carry 2, remainder 2, so it will be 25. 5 divided by 20, 25 divided by 5 is 5. So this is already a perfect square. We stop here. Now this is now giving us let me put it down here. It will now be 3 multiplied, that's okay, this is 25, answer is 1. I'm stopping here because this is a perfect square. This is what I'm looking for. So I have 3 multiplied by 5 multiplied by 25. So 3 multiplied by 5 already is 15 multiplied by 25. It's just a rough way you can use to find the factors. This is what we use when we are solving for LCM and HCF. So you understand, you remember that that's what we are using. So what you're just going to find is a factor that will give you a perfect square, and the other one is one that cannot be factorized further. So for the last one, 135 is the same thing as 9 multiplied by 15. So we have square root of 4 multiplied by square root of 15 minus square root of 25 multiplied by square root of 15 plus square root of 9 multiplied by square root of 15. So we have 2 root 15 minus 5, because square root of 4 is 2. So square root of 25 is 5. 5 root 15 plus square root of 9 is 3. 3 root 15. So now we can now add and subtract. We now have 2 minus 5 plus 3 square root 15. 2 minus 5 plus 3. This is already giving us 0 times root 15. So the final answer is 0. Sorry, final answer is 0. So we go to number 12. We have 2 root 135 minus 2 root 60 plus root 15 minus root 240. Now let's start. We are going to simplify before we add. So we have 2 multiplied by, now to factorize this, we've already done it here. If you look at it, it's 9 times 15. So let's use that. 9 times 15 minus 2 root, this 60, I think we've done it here. It is 4 times 15. So it's still the same, doesn't change. We have 4 times 15 plus, this is root 15. There's nothing we can do to it. That's the least it can be, least form of it. Then this 240, I've done the, if you do it, you're going to get 16 times 15. So this is the factors. So let's start simplifying it to give you 2 times root 9 times root 15 minus 2 times root 4 times root 15 plus root 15. This is this, this is that, so this is this. So don't get confused. Root 16 times root 15. So this will be 2 times root 9 is already 3 times root 15 minus 2 times root 4 is 2, so 2 times root 15 plus root 15 minus root 16 is 4 times 15. So the next is 2 times 3 is 6, so it will be 6 root 15 minus 2 times 2 is 4. So the 4 root 15 plus root 15 minus 4 root 15. Now we have the same roots all through. We can now add and subtract. So we have 6, that's 6 minus 4 here, plus, see what is here is 1. When you don't see any coefficient, then what is there is 1, because 1 times 15 is still root 1 time 1 multiplied by root 15 is still root 15. So here is 1 minus 4, or in parentheses root 15. So the final answer is 6 minus 4 is 2. 2 plus 1 is 3. 3 minus 4 is minus 1. So it will be minus 1 times root 15. So your final answer is minus root 15. So let's solve the final example we are solving for this class. Example 1D number 15. So this is what we have. Obviously, we can't do anything without simplifying it. So the first thing we are going to do, we are going to simplify. This will give us 16 times 14. Subtracted or minus, this will give us 9 times 14. Minus, this will give us 4 times 14. I've already shown how to come about these factors. The idea is to get a perfect square, then the least non-perfect square. So rounding off, this will give me root 16 times root 14 minus root 9 times root 14 minus root 4 times root 14. So root 6 is what? Root 16 is 4. Root 14 minus root 9 is 3 root 14 minus root 4 is 2 root 14. So now because both all of them have 14 as their root, now we can now carry out our operation, which is 4 minus 3 minus 2, or in bracket root 14. Is minus 1 times root 14. So your final answer is minus root 14. Please always be careful about this signs here, because if you miss it, you failed it. You understand? So these are final example for this class today. Thank you for joining us. And if you have any question, you can leave it in the comment section. See you in the next class. Thank you.